Hi everybody. On today's show we solve linear inequalities. Luckily it's the same thing that we do when we solve linear equations, except that one extra step of what happens when I divide or multiply by a negative number. There's that just one little property of inequalities that's a little different, but we'll get the hang of it. I promise you that. Kevin missed the last lesson and believes that the solution set to negative 5x is less than 30 is x is less than negative 6, because clearly Kevin divided by negative 5 and got x, negative 6, but wait a minute, warning. When I divide by a negative number, what happens? My sign changes. So explain what Kevin did wrong. Kevin did not change the sign. He changed the inequality, I'll call it. Change the inequality. When you divide by a negative number, that inequality has to become a less than, becomes a greater than, and a greater than becomes a less than. So let's jump right into it. Solve the linear inequalities and graph the solution set. So solve these linear inequalities here. Well, this first one's pretty straightforward. It's a nice two-step one. Add 6. 5x is less than or equal to 30. Divide by 5. And I got x is less than or equal to 6. So if I were to graph this, here's 6, 7, 8, 5, 4. 6 is included in the solution set. 6 is a solution, and I want to be less than it. So I'm going to go this way. So what are some numbers in the solution set? 4, 5, 6, I don't know, 4.5. 5.999, you can keep going on and on, but those are some numbers in the solution set. Any number that's colored blue works. Let's look at this one here. 2 times 5 minus x. Well, I know you're all going to distribute, even though I don't want you to, but let's say you distributed. That 10 doesn't have an x, so let's get rid of it. Negative 2x is less than or equal to 2. So when I divide by negative 2 here, warning, x is what? X is greater than or equal to negative 1. Notice my sign changed there. Notice my sign changed going down there. That little star means nothing, so I'll erase it. So when I graph my solution set, I've got negative 1, 0, negative 2. I've got a closed circle again, and I want to be greater than negative 1. Any number that I pick up here will work. So if I pick 0, that works. If I pick 1, 2, 3.5, any number bigger than negative 1, negative 0.4, any number bigger than negative 1 is a solution. So this next one looks scary. This next one looks scary because there's decimals, but luckily you've got a calculator to help you out. Let me add 4x to both sides so we avoid some negatives here. 3.6 plus 3.2x is less than 4.4. Subtract away 3.6. 3.2x is less than 8/10. Divide by 3.2. X is less than, if you simplify that, you get 1/4. X is less than 1/4. 0.25 also works as well. So when I go to graph this, well, let's say here's 0, here's 1. 1/4 would be right there. There's 1/4. And I want to be less than it. Notice I have an open circle here, because can I touch a 1/4? No. So I need to be 1/4 or smaller. So what are some numbers? 0, negative 1, negative 2. Any number that's smaller than 1/4 is a solution. Another sly thing it could have done here to get rid of all the decimals was to multiply everybody by 10. That would have been a little easier equation to work with without the decimals. But you've got a calculator. Use it. X plus 4 is bigger than 3 halves x minus 3. I see that 3 halves, so I'm going to scale everybody up by 2, and I'm allowed to do that. 2x plus 8, I doubled that side, so I'm going to double this side. When I double 3 halves, it gets rid of the 2 in the bottom. I get 6 halves, which really becomes 3x minus 6. This equation looks much nicer to solve. I don't want negatives, so I'm going to do that. 8 is bigger than 1x minus 6. 14 is bigger than x, which is fine, but I don't really like 14 is bigger than x. X is less than 14. That's what I'm going to say my real answer is. So that when I go to graph this solution, there's 14, 15, 13. I can't touch 14, so open circle, and I'm smaller than it. X is less than 14, or 14 is bigger than everything in my solution set. So what are some numbers that work? 13, 12, 0, negative 5. Anything smaller than 14, but not 14. 14 is not in the solution set. Oh, this looks beautiful. We get to distribute a whole bunch of times, so hopefully you're ready to distribute away. 8x minus 16. Remember, you're taking that negative 3 and distributing that. Minus 6x minus 3 is less than or equal to 7x plus 4. Oh, you got to take that negative 3 and distribute it again. Negative 3x minus 3. So now let's combine like terms. Let's look at this left-hand side here. I've got 2x's minus 19 is less than or equal to, let's look at the other side now. I'm just combining like terms, 4x plus 1. I'm going to subtract 2x from both sides. Basically, we're solving an equation again, except I've got that little extra step to look out for, and I'm not getting one answer, I'm getting a whole bunch of answers. Negative 20 is less than 2x. So now I divide by 2. Some people ask me at this point, do I flip the sign? Well, did you divide? Is your divisor a negative number? No, I'm dividing by a positive 2. So the sign doesn't flip. I know that was a negative number, but the sign doesn't flip because I didn't divide by a negative number. Negative 10 is less than x, so x is bigger than or equal to negative 10. That is my solution. So I've got all this room over here to graph it. Negative 10, negative 9, negative 8, negative 11, negative 12. Is negative 10 a solution? Yes, so it gets a closed circle, and x is bigger than it, so I'm going to show you that way. What are some numbers that work? Negative 10, negative 9, negative 8, and keep on going. Determine the smallest integer that makes this true. Well, it's not telling me to do this, but I should probably solve this inequality. Should probably solve this inequality to clean it up. These are on the same side, so I'm going to combine like terms. Subtract 7. Uh-oh, I just divided by a negative 8, so yes, that's negative 1, but my sign has to change. I went from less than to greater than. But I haven't answered the question, what is the smallest integer? Well, x is bigger than negative 1. Here's negative 1. I can't touch it, but I need to be bigger than it. What is the smallest integer that makes this true? Well, it's not negative 1, so my answer is going to be 0. 0 is the smallest. Be careful. Solve the inequality, but make sure you're actually answering the question that they're asking. Given that 2x plus ax minus 7 is bigger than negative 12, determine the largest integer value of a when x is negative 1. So they're telling me x is negative 1. Negative 2x, oh, I'm sorry, negative 2, because x is negative 1, minus a minus 7 is bigger than negative 12. I took that and I plugged it in. Combining like terms, negative a minus 9 is bigger than negative 12. Add 9. Negative a is bigger than negative 3. Divide by negative 1. Warning, warning, warning! A is less than positive 3. So there's 3. Open circle, I've got to be smaller than it. So what's the largest integer? Well, 3 is too large because it's not in the solution set. So 2. 2 is my answer here. Don't get scared when there's extra letters. You can do it, I promise you. Because we get to problems like this. Given a, b, and c are all positive, solve for x. So let's subtract b and divide by a. But am I dividing by a positive number there? Yes, I am, so I don't need to change the sign. X is less than or equal to c minus b over a. Nice. I see this fraction, so let's multiply by b. ax plus 2 is bigger than bc, b times c. And again, I multiplied there, but it was positive, so I don't need to change any signs. I'm going to divide by a at this point. I know some of you probably distributed, but I'm going to divide by a. Again, positive, don't need to worry. Subtract 2, x is bigger than bc all over a minus 2. I didn't need to change any signs because a and b were both positive. And finally, this is a nasty question, but I want to talk about it because it's doable. It's just got a little, just has some quirks that we got to talk about. Given that a is bigger than b, solve for x. Solve for x means get x alone in terms of a and b. So let's distribute. And I'm solving for x, so let me get my x's together. So we'll add 3b. bx is bigger than or equal to ax plus 10b. Middle school dance. Everyone with an x on one side, everyone without an x on the other side. So let me get my x's together over here. bx minus ax is greater than or equal to 10b. Well, notice both of these have x's. So let's undistribute. Let's apply the distributive property, but in reverse. What times x is bx? b minus a. And finally, divide by b minus a. So my final answer is x 10b over b minus a. But wait a minute, I just divided by something. Is b minus a negative? Well, let's think about it. A is bigger than b. So let's say a is 7, b could be 4. Is 4 minus 7 negative? Yes, because a is bigger. So this b minus a thing comes out negative. So be careful, you had to flip the sign there. Notice the sign change. X is less than, I started off greater than, x is less than that. This was a nasty question because you had to deal with the extra letters, and then they threw in this curveball here that b minus a was actually a negative number. Again, this is one of those hard problems I hope you can do, but if you can't, let's focus on getting the basics down and work our way up to this. That's lesson 10. We've got one lesson left in this unit. See you then.